This is part 2 of the introduction chapter of the textbook. So last, in the part 1 section, we left off here at the slide, which we were talking about ecosystems and the different services that ecosystems provide. Right now I'm going to take you through examples of the provisioning, regulating, cultural, and supporting services that ecosystems provide. So the provisional services they supply us with resources, food, water, air. Humans can modify, of course, to increase services, and we have done this where we have been able to figure out ways to exacerbate resources or be able to use those resources to the greatest level. It doesn't mean that we then can, of course, recreate resources, but we can use them to the greatest level. For example, we have been able to change grasslands to cornfields, so we've been able to feed more people. Doesn't mean it's always best for the ecosystem or for the person eating that food, but it is a way to increase that. So the problems, and remember the drawbacks, are now that those fields now support fewer species because we have made them into a monocrop instead of leaving the biodiversity there. The regulating services, of course, ecosystems are able to regulate climate for us. They're able to provide the flow of water that we need. So through the water cycle, believe it or not, ecosystems really do absorb pollutants from the atmosphere, but there's a point where there's a tolerance that's met. So we're getting to that point where there's only so much that the ecosystems can absorb, and then unfortunately after that we have large amounts of pollutions that the ecosystem just can't regulate with. Cultural services, of course, ecosystems provide those what we call intrinsic values. So they provide cultural services to us, meaning they hiking, outdoor activity, ecotourism, holy sites. In some religions, water is very, very important. So this is what ecosystems provide to us as well. Supporting services, the basic ecosystem processes, so the soil, such as the nutrient cycles, soil formations that are needed to maintain other services. For example, the bees and other species provide supporting services by ensuring flowers are fertilizers, which then allows fruits to be formed. So a couple important things to remember in ecosystem function, and these are things that you'll learn in physics and in some other courses that you'll learn. But matter and energy are neither created nor destroyed, and these are really important for you to remember, these 4 fundamental principles of ecosystem function. So matter and energy are neither created nor destroyed. Ecosystems are open to gains and losses of energy and matter. Ecosystems processes are self-regulated, meaning they regulate themselves. We don't regulate for them. Humans can interfere in that regulation, and then we cause problems to those cycles. Ecosystems change is essential and inevitable, and this is something that's really important. As humans, we tend to think that change is a negative, but ecosystems actually look at it in the other way. It's definitely essential to the growth of the ecosystem, and it's also inevitable. So ecosystems are going to change, sometimes for the good, sometimes for the bad, and all of that is part of a normal process. So as humans, we can take this into account. I try and wake up every morning and say, listen, change is important. It's inevitable. So I need to be okay with some changes that might take place in my life today, because that is just part of life. So these are just examples, and this is a lake, and you can see that this is Lake Mead near Las Vegas. It's gradually shrinking as water use exceeds the water supply, and this is a big problem. So the water level should be up here, and this is all the water that's supplied to Las Vegas. This actually was dammed to create this reservoir, and then this water is pumped to Las Vegas, and as you can see, that it's lowering, and which is a problem. So this ecosystem is changing. It's inevitable. We need to change our ways to adapt to that, of course, but we won't stop using water. So this is a big problem, especially in Vegas, that actually give people tax credits for putting in artificial grass, for having exterscaping. Las Vegas is trying to conserve water the best that they can, but we don't forget, we built a city in a desert, so it's really, really impossible to do that. This is another good example. This is eutrophication of a lake, which means that algae created is in there, and what we need is that process to change. So what happened is that we either put sulfites or nitrates in this water through runoff, and usually that happens when we wash our cars with soap. That water gets into the system, or we use fertilizers, and then what happens is those fertilizers help the algae to bloom faster. That algae, if that blooms too fast, it'll suck that oxygen right out of that water and kill all the organisms in there. So there's lots of issues with this. And so here's a couple just things we're going to talk about. We're going to go into depth into each principal ecosystem function. Energy and matter can neither be created nor destroyed. Remember, something cannot be created from nothing, and this is important, the law of energy and mass consumption, which means everything goes somewhere. So just because you burn coal doesn't mean that the coal goes into the atmosphere as a different as a pollutant. So matter is created or destroyed. Ecosystems are open, so matter and energy flow influence the function, interactions, and content of ecosystems is really important. So ecosystems are open. While we think there might be boundaries that are drawn, that's not really true. In ecosystems, don't forget, matter and energy can flow through these surrounding areas, so that's really important. You know, for example, heat and streams can flow in and out of an ecosystems. There are gains and losses of matter and energy, which influences, of course, ecosystem function. This is just a really good showing you that while we have a border between two countries through Texas and Mexico, yeah, we built this crazy border there, but it doesn't mean that the ecosystems change between those two areas. So, you know, the ecosystems are kind of the same in these areas, even though, you know, we built this border. It doesn't mean that, you know, the pollution that comes from river systems in the United States that flow south into Mexico, you know, this border doesn't stop that. It stops, of course, what people consider people, right? But it doesn't stop pollutants from flowing from one area to the other. Processes are regulated by biotic and abiotic factors. This is really important right here, positive and negative feedback loops. So positive feedback loops are actually really bad for the environment because we're really used to seeing the word positive meaning a good thing. Well, in terms of feedback loops in the environment, it's actually a bad thing. So positive feedbacks reinforce that negative behavior. Negative feedback loops actually reverse the directional change and fix the problem. And the two of these together are what helps create homeostasis in the environment, which means it helps to bring back that equality, okay, or that kind of that area where everything's back to normal again. And so here's a really good example. Right here is what we have as nutrients increase, algae growth increases. Okay, so for example, if we increase fertilizers and that runoff happens into a river system, then those nutrients increase algae growth. So then what happens is that the high algae population deplete nutrients because they use those nutrients, and algae growth, of course, begins to decline because there's not enough for it to feed off of to keep growing. And then as that algae growth declines, nutrients, of course, then begin to increase again, and then the cycle continues. This is what we call a negative feedback loop, because do you see how it's correcting itself? So the nutrients increase, so of course algae increases, so it would be like the food increases, the population increases. But what happens when the food runs out? The population then starts to decrease again. As the population decreases, then the food increases again, right? And then the population starts to increase. So that's a negative feedback loop. It helps to fix that change. This is what we call a positive feedback loop, and this is the good example, is that, you know, forest loss increases erosion. So when we cut down trees, the roots of those trees actually keep that soil intact. And when we cut down those trees, okay, now all of a sudden that soil is exposed, which increases erosion. Okay, and then what happens is accelerated erosion then accelerates forest loss. And the reason that that happens is that when we have all these mudslides, because that soil now is eroding, it then wipes out more trees below where the clear cutting happened. So it's actually really bad, and this is why we call it a positive. It reinforces that change, which is really bad, meaning that accelerated forest loss means increase in soil erosion, and then that soil erosion then keeps the problem happening, because then mudslides happen and it wipes out more trees, and in fact then that silt gets into waterways and it creates a major problem. Silt in waterways that ends up in the ocean actually is one of the leading causes of coral reef destruction, besides, of course, the increase in water temperature. Silt infiltration from clear cutting that then ends up in the river systems and ends up back in the ocean is another major reason for coral reef destruction. So the fourth principle of ecosystem function is change is inevitable and essential. So ecosystems are constantly changing. They respond to external and internal actions, and it doesn't mean that everything's bad. Sometimes good comes out of bad. Storms are actually really good for the environment. They actually, some forest fires that are not, of course, intentionally set are actually needed. There are certain types of trees where their pine cones are tightened, and until they reach heat, until they feel heat at a certain temperature, then those pine cones open and release seeds. So there are certain things that actually, that also succession of forests. So if a forest fire comes through and wipes out a whole forest, it leaves room for new growth to happen. So there's lots of reasons. In fact, us humans try and recreate that. We do sometimes what you call controlled burns, and controlled burns are purposely set by fire departments to clear out. One of the main reasons is pine needles, right? Pine needles are not deciduous trees, they are evergreens, and what happens is those pine needles fall, and those pine needles actually have a waxy coating on them, so they actually hardly ever degrade. It takes a really long time for them to degrade. If you've ever been to the pine forest, you'll see there's like layers and layers of pine needles on the ground, and they turn brown and they're really like kind of prickly. And what happens is when these cover the ground to a large extent, no new growth can happen. So what happens is a lot of times controlled burns are happen where firefighters come in and set a fire for a specific area to burn those needles out so that new growth can happen in those areas. Believe it or not, floods are actually important. And we don't realize this, but at the Jersey Shore, actually, hurricanes are important, floods are important. I know we live on these barrier islands, but remember, the barrier islands are meant to move. They're meant to protect the mainland. And these barrier islands are what protects the mainland from hurricanes, is that for every mile of wetlands that we have, it knocks a hurricane down by one category. So really those barrier islands were not meant to be built on. So all of our Jersey Shore locations are on barrier islands. They weren't meant to be built on. Now what we're trying to do is keep those barrier islands stationary by, of course, pumping sand in. It doesn't mean it's always the best thing to do, because those barrier islands were supposed to move. You're supposed to create new land. The oceans create new land. They decrease beaches. Then they throw that sand somewhere else. But we want everything stationary now because we built on it. But really the main point of those barrier islands was to protect the mainland from hurricanes. And we have forgotten that. So change is inevitable and essential in ecosystems, and sometimes it's for good. Excuse me. Let me take a sip of water. So this, you can see here, this is an ecosystem in Silver Glen Springs. It's a palmetto jungle in the Ocala National Forest in Florida, and it was disturbed by Hurricane Francis in 2004. But you know what? These areas leave areas for new ecosystems to form. Is that when fallen trees happen, guess what? These new trees can grow up, because sometimes those big trees block the sun from coming in. So it's not always a bad thing. So we were talking about sustainability before, and we're just going to briefly talk about it again. Actually, I'm going to make a part 3 of this video and we'll finish out the chapter. So let's stop here, and in part 3 of the chapter we'll finish the PowerPoints for this session.